students, I hope all of you are doing good. Let's start today's chapter, Algebra. In this chapter, we will discuss about these topics. No more. The word algebra comes from the Arabic language, that is al-zabr, that is restoration. Okay? Introduction. In this chapter, we shall study about a new branch of mathematics, that is algebra. Algebra is to mathematics as a shorthand is to writing in everyday life. In algebra, we use letters such as X, Y, Z, etc. in addition to numerals to solve various problems. When you feel like you have got a handle on mathematics, suddenly all X's and Y's is sprouting up all over like grass on bare field. But don't get afraid, because variable X, Y, Z are the letters. They represent numbers. They work as a shorthand for branch letters in English. The long, complicated, ordinary sentences can be reduced to short algebraic statement by using letters and mathematical symbols. For example, consider the following situation. Think of a number, add 6 to it. Multiply the result by 3. The final number obtained is 30. If we use the circle in place of the number, we think then the above statement can be written as C. We thought of a number, okay, like the circle, then we will add 6 into it, then we'll multiply by 3, and then the answer we got is final number is 30. Let's take another situation. Think of a number multiplied by 2, subtract 3 from the product, and result obtained is 9. So again, let the number we thought of it be represented by this square. Okay, then the above statement can be written as the square is multiplied by 2 and then 3 subtracted from the product, and the result is 9. Okay, we can use different symbols for different numbers. Okay, no more. Indian mathematician Brahmagupta wrote higher level book Brahmsputra Siddhant. In this book, he described the first complete arithmetic solution, including zero and negative solutions to quadratic equations. Okay, let's do exercise 11.1. Use these 3 symbols, that is square, triangle, zero, etc. and mathematical symbols to write the following statement. Okay, we can use any of these symbols. Okay, I think of a number. Okay, let's say the number is the circle. Okay, first read the question, okay, then understand what to do, what has been asked in the question. Okay, I think of a number. Okay, I thought of a number, right. Next, add 5 to it means plus 5 to it. The result is 12. Okay, see how simple and easy this is. Okay, now characteristics of algebra. The use of letters, which are used to write rules and formulae, generally is a main feature of algebra. Letters are used for unknown quantities, using which problems of day-to-day life are solved. As letters stand for numbers, basic operations, these operations can be performed in the same way as numbers, due to which we form algebraic expressions and then study these expressions and their properties. Patterns. A pattern, whether in nature or art, relies upon 3 characteristics: a unit, repetition, and a system of organization. In carpets, floor tiles, wall designing, saris, etc., when a particular design repeats, it becomes patterns, right? We can also say that when things are arranged following a rule or rules, it becomes pattern. There is a pattern in these numbers. 2, 7, 12, 37, 30, 17, 22, and so on. The rule is start from 2 and add 5 each time. Okay. Number 1, dot pattern. Look at the pattern shown on next page. In the arrangement of dots, we see that both arrangements of dots represent a rectangular number 15. From these arrangements, we find that 5 into 3 is equals to 3 into 5. Okay, have a look. Following are also true. 2 into 6 is equals to 6 into 2. 3 into 4 is equals to 4 into 3. And 7 into 8 is equals to 8 into 7, etc. Let A and B stand for any 2 counting numbers. It is always true that A into B is equals to B into A. Here A and B are substitutes for counting numbers. The use of letters A and B in place of numbers help us to tell about all the counting numbers without listing each of them. Okay, see, 2 into 4 plus 2 into 3 is equals to 2 into 4 plus 3. The above dots at LHS, that is left hand side, show what? See, 2 into 4 plus 2 into 3. right? This is plus. Okay. From the arrangement of dots at RHS means right hand side. What we got? Okay, we'll calculate first it. 8 plus 6 is equals to 14. Okay. Now the arrangement of RHS is 2 into 4 plus 3 is equals to 2 into 7, that is 14. Right. So that means LHS is equals to RHS. Similarly, we can also have the arrangement of dots for each of the following, like this and this. Okay. The above pattern can be written as follows using letters A, B and C in place of numbers such as A into B plus A into C is equals to A into B plus C. Number 2 is number pattern. A, the even natural numbers. The first even number is 2, that is 2 into 1. The second even number is 2 into 2. The third even number is 2 into 3. And the fourth even number is 2 into 4, right? And the nth even number is 2 into n, that is 2n. B, the odd natural number. The first odd number is 1. So how we obtain 1? 2 into 1 minus 1. Okay. Then second odd number is 2 into 2 minus 1. Third odd number is 2 into 3 minus 1. Okay. So this is 5, this is 3, this is 1. And the nth odd number is 2, this is the formula, 2 into n minus 1, that is 2n minus 1. See, a list of numbers that follow a certain pattern, example 1, 4, 7, turn 13 starts at 1 and jumps 3 every time. For example, 1, 2, 4, 8, 16, 32, 64 doubles each time. Similarly, numbers, we have so many patterns. Number 3, matchstick pattern. Matchstick patterns are helpful in discovering ways to represent certain type of numbers in the form of different shapes using matchsticks. Rules to find numbers of matchsticks used in a given pattern. 1. Write the number of matchsticks used in the nth shape in terms of n. 2. Find the general rule to find the nth term. Example 1. Find out the pattern to form this through matchsticks. Okay. If we place these numbers in column, we can easily understand the pattern. See. Can you see the pattern? So number of these 1, 2, 3 and 4. So number of matches used here 3. Have a look. 1, 2, 3 and then number of matchsticks here we have used 5. See, 1, 2, 3, 4, 5. Okay. Similarly 7 and 9. So the pattern formed is what? 2n plus 1, where n is a variable, right? Example 2. Find out the pattern to form this through matchsticks. So placing the numbers column wise, we can understand the pattern. See, number of these triangles. For one triangle, we have used 3 matchsticks. For 3, we have used 6. 1, 2, 3, 4, 5, 6. For 3, we have used 9. For 4, we have used 12. For 5, how many matchsticks will have been used? Let's find out. The pattern formed is equals to 3 into n, where n is a number of variables. So hence matchsticks needed to form 5 such patterns is 3 into 5, that is 15. And to form 6 such patterns is 6 into 3 or 3 into 6 is equals to 18. Okay, so you will get 15 here and 18 here. Similarly, you will do example 3 also. Let's do exercise 11.2. Look at the patterns and fill the missing boxes. Also state the rule which connects the quantities in the different columns. Find the general rule for n in each case. Okay. See here, numbers are increasing and here what we are getting? 2, 4, 6. So here rule is 2 into n, right? See, 2, n is 2, so we get 4. Okay. Then 2 into, if n is 3, we got 6. And 2 into 4, if n is 4, we got 8. Okay, then we have to find this. 2 into 6 is equals to 12. 2 into 7 is 14 and n is 2n. Right, students? Idea of a variable. As in the introduction section of this chapter, we have used symbols such as square, triangle, circle, etc. to represent an unknown number. As the number of variables increases, it becomes difficult to find different symbols. Thus, we use variables such as x, y, z, a, b, c, etc. instead of symbols. 5 of the most important concepts you will need in algebra is variable, term, coefficient, expression, and like terms. It is not important that you memorize these definitions, but you should understand each one and be able to define the concept in your own words. Number 1, variable. It is a letter or symbol used to represent some unknown quantity. Okay, always remember, variable is a letter or symbol. Okay. Number 2, term. It is a symbol or group of symbols separated from other symbols by plus or minus signs. For example, in 3x minus 5y plus 7xyz minus 2, there are 4 terms, that is 1, 2, 3, 4. Okay, contain a number and or several letters. Here 7xyz is a single term. In any term or numeral is written first and letters are usually put in alphabetical order. Okay. Number 3, coefficient. Numerical coefficient is a number that multiplies to the variable. Okay. For example, in 2y, the numerical coefficient is 2, right? Number 4, expression. Sum or difference of and or more terms can be referred to as an expression. For example, 3x minus 5y plus 7xyz minus 2 is an expression. 5, like terms. They contain the same variable but differ in their numerical coefficients. Like terms can be combined. For example, 3x minus 5y plus 4x, here 3x and 4x are like terms, so it can be reduced to 7x minus 5y. Thus, in algebra, we use numerals as well as variables to convert statements into mathematical form. These numerals and variables along with arithmetic signs, that is, these form algebraic expression. For example, we have to write the statement sum of two numbers is 16, then we may take one number as x and other number as y and write the above statement as x plus y is equals to 16. Also, a number multiplied by 6 gives 36 can be written as x into 6 is equals to 36. No more. In general, coefficient of any variable is the term excluding that particular variable. For example, in 7xyz, coefficient of y is 7xz, but numerical coefficient of xyz is 7. Okay. Now, example 4. Write the following statement using variables and numerals. The product of two numbers a and b. Okay. Product of two number a and b and added to 5. Okay. Added to 5. You can also write it ab plus 5. Right. Number 2, the sum of x and twice of y. Okay, so you have to do a sum of what? Sum of x plus twice of y means 2y. Number 3, area of triangle is half the product of its base and heights. Okay, area of triangle is equals to half the product of its base and height. Okay. So, half into b into h. Now, let us do exercise 11.3. Write the following using numbers, letters and signs of operations. Sum of x and y. Sum of x and y added to 3. And number 2, product of a and b, that is ab, subtracted from 10. So, 10 minus ab. This is the expression. Right. Third, x divided by y, x divided by y. Right, students? Now, use of variables in common rules. Here in this section, we will learn that how we can express common rules with the help of variables. Rules from geometry. A, perimeter of a square. We know that perimeter of any polygon is sum of the length of its sides. A square has 4 sides and all of them are equal in length. Say A, perimeter of a square is equals to sum of the length of its 4 sides. We already know that is a plus a plus a plus a, that is a 4a. Here variable a, okay, a, variable is a, helps us to write the general rule for perimeter of square, which is easy to understand and learn. If we express perimeter of a square by p, then the relation between perimeter of a square and its side can be expressed as p is equals to 4 into a, that is perimeter of a square is equals to 4 into side, right? B, perimeter of a rectangle. A rectangle is a polygon with 4 sides. Both pairs of opposite sides of a rectangle are always equal in length. So the lengths of AB and CD are equal, and also BC and AD are equal, right? So then perimeter, let AB is equals to L is equals to CD and BC is equals to B is equals to AD. Then perimeter P of rectangle ABCD is equals to AB plus BC plus CD plus AD. L plus B plus L plus B is equals to 2L plus 2B is equals to 2 in bracket length plus breadth. That therefore relation between perimeter of rectangle whose length of sides are L and B can be expressed as P is equals to 2 into length plus breadth. Okay. Rules from arithmetic. A. Commutative property of addition of two numbers. We know that in adding two numbers, if we change the order of numbers, it doesn't change the sum. This property is known as commutative property of addition of two numbers. For example, 5 plus 8 is equals to 8 plus 5 is equals to 13. If we use two variables A and B to denote the numbers, then this property can be stated as A plus B is equals to B plus A. Okay, no more. All the properties like commutative, associative, distributive properties can be expressed in form of algebraic expression statements, right? B. Commutative property of multiplication of two numbers. We know that product of two numbers remains same irrespective of the order in which they are multiplied. This property is called commutative property of multiplication of two numbers. For example, 6 into 7 is equals to 42. Also 7 into 6 is equals to 42. Thus, if we take two numbers as A and B, then this property can be stated as A into B is equals to B into A. C. Associative property of addition. We know that in adding three numbers, if we change the grouping, it doesn't change the sum. This property is known as associative property of addition of three numbers. For example, 3 plus 4 plus 7 is equals to 3 plus 4 plus 7. Okay, you have studied and learned these properties in your earlier classes also. Okay. If we use three variables A, B and C to denote the numbers, then this property can be stated as like this. Okay, A plus then in bracket B plus C is equals to A plus B in bracket plus C. Okay, now D, associative property of multiplication. We know that in multiplication of three numbers, if we change the grouping, it doesn't change the product. This property is known as associative property of multiplication of three numbers. For example, 3 into 5 into 7 is equals to 3 into 5 into 7. If we use three variables A, B and C to denote the numbers, then this property can be stated as A into B into C is equals to A into B into C. Okay. E. Distributive property. Let A, B, C are three variables representing any three numbers, then distributive property of multiplication over addition can be stated as A into B plus C is equals to A into B plus A into C, right? For example, let A is equals to 5, B is equals to 3 and C is equals to 2. For example, then according to this distributive property, we will write here, see 5 into 3 plus 2 is equals to 5 into 3 plus 5 into 2. Okay, 5 into 5 is equals to 15 plus 10. 25 is equals to 25. Okay. Example 6. Apply the commutative property of addition for 9 and 6. Okay. Here you have to apply the commutative property. So, commutative property, what does this say? A plus B is equals to B plus A. Okay. So, 9 plus 6 is equals to 6 plus 9. That is 15 is equals to 15. Right, students? Next, algebraic expressions. Any expression consisting of numerals, variables or combination of numerals and variables connected by one or more of the symbols plus or minus is known as algebraic expression. For example, 3x plus 2y, 5a plus 7c, 4a plus 5b, 6a plus 2b are all examples of algebraic expression. Okay. Types of algebraic expressions. Number 1. Monomial. An algebraic expression containing only one term is called a monomial. For example, 4, 4y, 8x, 2xy, etc. 2. Binomial. Bi means 2. An algebraic expression containing two terms is called a binomial. For example, 2x plus 3y, 4x plus 8y, 2abc minus 3ab, etc. 3. Trinomial. An algebraic expression containing three terms is called a trinomial. For example, 3x plus 4y minus 7. Okay, it has three terms 1, 2, 3 and 5ab minus 3a plus 4b, etc. polynomial. Poly means many. An algebraic expressions containing 1, 2, 3 or more terms is called a polynomial in general. For example, 3x plus 4y minus 7, 2a plus 3b minus 4c plus 7d, 5a plus 2b, etc. are all polynomials, right? Now, expression with variables. We can form algebraic expression from variables. The algebraic expressions are obtained by the operations of addition, subtraction, multiplication, division on variables and numerals. Let us see the following expressions. A, x plus 9, which is formed by adding 9 to x. 2, 3x plus 4y formed by sum of 3x and 4y. Okay, whenever there is a sign of addition, we will write it as sum. Okay. 3, a minus b, b subtracted from a. 4, 5 minus t, t subtracted from 5. 5, 5x, x is multiplied by 15. Okay. And 6, ab, product of a and b. 7, y by 5, y is divided by 5 and 100 by x, 100 is divided by x. Okay. So, x plus y is the sum of x and y. Z plus 3 is a sum of z and 3. Okay. 3 subtracted from x is x minus 3, or you can say difference of x and 3. The difference of x and y is x minus y or y minus x. Okay. But remember, x minus y is not equal to y minus x. See, as we know that repeated addition is called multiplication. So, y plus y plus y plus y plus y is equals to 5 into y, or you can briefly write it as 5. The product of x and y is x into y, can simply be written as xy, right? D. As in case of two numbers, a divided by b. Okay. A divided by b is read as a divided by b or a by b. Simply. So, 50 divided by a, or you can say 50 by a, both are equal. Okay. Let x and y be two variables. Are x divided by y and y divided by x equal? Really not. Meaning x divided by y is not equal to y divided by x. For example, 2 divided by 4 is not equal to 4 divided by 2. Because 2 divided by 4 is what? Half. And 4 divided by 2 is what? 2. So, these are not equal. Example 6. Which out of the following are expressions with the numbers only? Okay. The following are expressions with the numbers only. Okay. Can you see in this? This is the expression here, only numbers are given. Okay. And this is also an expression where only numbers are given. Okay. Let's do exercise 11.4. Write the following statement using variables, numerals and signs of operations. The sum of A and thrice of B. The sum of A and thrice of B. Okay. Number 2. Selling price is equals to the cost price plus profit. Selling price is equals to cost price plus profit. And 3, the perimeter of a square. Perimeter of a square is 4 times its side, that is 4 into side, right? Next, equation. An equation is a mathematical statement that asserts the equality of two expressions. Equation consists of the expressions which are to be equal on opposite sides of an equality sign, as in x plus 6 is equals to 9, 4 minus y is equals to 7. The part of equation to the left of sign read as equal. This sign is equal, okay, and is called the left number or LHS, that is left hand side of the equation. And the part of the equation to the right of the sign equal is called right side number or right hand side, that is RHS of the equation. In the equation, 4x plus 16 is equals to 25. Okay, this 4x plus 16, this is the expression. So, here the expression 4x plus 16 is equals to 16. See, this is LHS and this is RHS. Okay. So, 4x plus 16 is the LHS of the equation and 25 is the RHS of the equation. The letter x is called this one, x. is called unknown or variable. Okay, this is known as variable. Solving an equation means finding the value of unknown or variable. If the equation is 5x is equals to 15, then x is equals to 3 is the solution of the equation, because 5 times 3 is 15. We also say that 3 satisfies the equation, 5x is equals to 15, or 3 is the root of the equation. Okay. Now, solution of an equation. A number which substitutes a variable makes the LHS and RHS of the equation balance is called a solution of the equation. Solving the equation by trial and error method. Finding the value of the variable to make the equation balance is called solution of the equation. To solve an equation by trial and error method, we take different values of the variable and substitute it in the equation. When for a particular value of the variable, LHS and RHS of the equation become equal. That value of the variable is called solution of the equation. Okay, example 13. Find the solution of the equation 3x plus 2 is equals to 8 using trial and error method. Okay. So here is the expression given to you, equation given to you, 3x plus 2 is equals to 8. Okay. So we will put value of x starting from 0 till we get both sides equal, that is LHS and RHS. Okay. So first we will put 0 here, plus 2 is equals to 8. 3 into 0 is 0, plus 2 is, so LHS is not equals to RHS. Okay. Next we will put 1 instead of x, plus 2 is equals to 8. 3 plus 2 is equals to 8, that is 5 is not equals to 8. Here also LHS is not equals to RHS. Then now what will we write? We will put 2 instead of x. 2 plus 2 is equals to 8. 3 into 2 is 6. 6 plus 2 is equals to 8. So 8 is equals to 8. Here LHS is equals to RHS. So x is equals to what? X is equals to 2 is the solution of the given equation, right? Solving the equation by method of transposition. Trial and error method is not a practical and convenient way of solving the equation. Now we learn to solve the equation by method of transposition. The steps are as under. Number 1. If same number is added to both LHS and RHS, equation remains unaltered. Number 2, if the same number is subtracted from LHS and RHS, then equation remains unaltered. 3, multiply or divide both the sides of the equation by the same number, then equation remains unaltered. 4, transfer any term of the equation from one side to the other by changing its sign, that is while transferring, plus changes to minus and minus changes to plus. 5, transpose the numerical coefficient of any quantity from LHS to RHS or RHS to LHS as its denominator. The denominator gets transposed as numerator and vice versa. That is, multiply changes to divide and divide changes to multiply. Remember that, okay? Let's solve the equation. X plus 5 is equals to 8. So what will we do? We will add minus 5 to both sides. So x plus 5 minus 5 is equals to 8 minus 5. Okay. Plus 5 minus 5. So x is equals to 8 minus 5 is 3. So x is 3 is the solution of the given equation. Now you can check also, what will you do? You will put the value of x in this equation. Value of x is what? 3. Right? So 3 plus 5 is equals to 8. So 8 is equals to 8, that is LHS is equals to RHS, that means the answer is correct, right? Okay, similarly you will do second part also, okay? Now, application of algebraic equations in practical problems. The most important application of algebraic expression is in solving word problems. We transform the word problem in the symbol of algebra. Let us look at the following word problems and their transformation into algebraic form. A. 3 multiplied by a number gives 21. Okay. 3 multiplied by a number, which number? We don't know. So 3x is equals to 21. If we take the number as x, then the above statement can be written as like this. Okay. B. Rima's age is 4 times her younger sister Anu's age, and sum of their ages is 25. Okay. So let Anu's age be what? X. Rima's age, Rima is 4 times, so 4x, and the sum of their ages is 25, that is x plus 4x is equals to 25. X plus 4x, 5x is equals to 5, okay. See, the sum of 1/5 of x and 1/4 of x is 5. Okay. First, sum of what? 1/5 of x, that is x by 5, and 1/4 of x is 5. Okay. Let's do exercise 11.5. Number 1. Write the equation for each of the following statements. A number added to 5 gives 12. A number added, let the number be x, y, z or a, b, c. A number added to 5 is equals to 12. Okay, this is first part. B, A part and B part. A number subtracted from 10. Number subtracted from 10 is equals to, gives 2. Right? You can write any variable here, either a, b, c, d or x, y, z. Okay, it's totally up to you. Right, students? Now you will do practice of the remaining questions by yourself.